Welcome viewers to my YouTube channel. Today we continue with wave motion. The aspect we're going to look into today will be on properties of waves. Now we have many properties of waves, out of which 4 are said to be common properties. Now the 4 common properties of wave we have reflection, we have refraction, we have interference, we have diffraction. So these are the 4 common properties of waves. Then again, we have another one, but not among the common properties, which is polarization. Polarization is only applicable for those waves of which their direction is perpendicular to the direction of the source that generated them. Hence, we term them transverse waves. So it's only transverse waves that undergo polarization. Now, coming to this reflection, we've seen the rays, and that tells us that we have types of rays. So we can classify rays under reflection into 3 parts. We talked about rays as a path through which light travels or through which waves travels. So ray is just a single line, a line that represents the path through which what? Light, or through which any other waves travels. So in that very case, we have the one known as incident ray, the incident ray, the reflected ray, and the normal ray. Now let's use a sketch to explain this. If I have a plane surface, let's say I have this very plane surface. Now, if a ray, maybe from, let's say I have a torchlight here. Now from here, the ray from this very torchlight now hit this surface. Now, the ray will bounce backwards through this very path. Okay? Now, from this point at which the ray bounces off, if I get a line that is perpendicular to the very surface, then I have what we call 3 rays here. Now look at the ray that moves from the source, or that is being produced by the source, is said to be incident ray. Incident ray, okay? So in that very case, we can now say that incident ray is the original ray that emanates from the source. Okay, that's the original ray. Now, the moment it hits the surface, it bounces back. Now, the bounced ray, or the ray that bounced off from the surface, is said to be what? Reflected rays. Reflected rays. Now, this reflected ray, in that very case, could now be termed as a ray that bounces off from the surface. It is as a result of what? Incident ray hitting the surface. So it is the ray that is produced as a result of reflection. Hence we term it reflected ray. So it's the ray that bounces off from the surface. Okay? Now, the very line that is perpendicular to the surface, any ray that passes through it must also return back through that same path. Hence, we term it what? Normal ray. Okay? So the line itself is said to be normal line, because a normal line is a line that is perpendicular to a reference line. So in that very case, normal ray is a ray that passes through the normal line. Now that gives what? The 3 rays we have under reflection. So in this very case, when this very ray hits this very point will now be termed point of incidence. The point of incidence. Or you can also call it point of reflection, because from that very point, the reflected ray emerges out. So at this very point, this incident ray can be measured from the normal. The angle the incident ray met from the normal is known as what? Angle of incidence. Hence, here it becomes the angle of incidence. which is the angle between the normal line and the incident ray. Then again, the reflected ray also made an angle from the normal. If you measure this very angle is said to be what? Angle of reflection, which is angle made by the reflected rays from the point of what? Reflection. It is measured from the normal. Hence, you can also say that is the angle that exists between reflected ray and the normal. While incident angle is the angle that exists between incident ray and the normal. So at this very point, remember all takes place from the point of incidence. So let's look into the diagram there. Let's see more of the parameters we can get from it. Now, if we have here as a normal line, now a ray that incidented at this very point will reflect through this very path. Now we have angle of what? Incidence. While here is what? Angle of reflection. Now these rays would have moved through this very path if not this very surface here. But because of the surface, the ray could no longer move through this very path. Rather, it deviates and starts moving through this path. Which means this reflected ray can also be termed what? A deviated ray, because it deviates from its path. So that angle of deviation is what we call angle of deviation. Yes. So the angle of deviation is represented with D. So you may be asked to find angle of deviation. Now, this angle of deviation, you've seen angle on a straight line, which is D plus R plus I, which is equal to 180 degrees. So we can get angle of deviation. Now, under the laws of reflection, one of its laws says that the angle of incidence is equal to angle of reflection. So for reflected rays, you see its angle. It is always equal to angle of what? Incidence. So if angle of incidence is 10 degrees, angle of reflection will still be 10. So in that case, R could as well be equal to I could as well be equal to R. So in that case, we have D plus, maybe if R becomes I, we have I plus I giving us what? 2I equal to 180 degrees. So you can now say that D is equal to 180 degrees minus 2I. So you have a formula for calculating what? Deviation. We've seen that one of the laws of reflection says that the angle of incidence is equal to angle of reflection. So apart from this, we have another law of reflection. We may term it second law, whichever way. So we have angle of reflection, the angle of reflection incidence being equal to angle of reflection. That is first law of reflection. That's the first law of reflection. Then coming to the second law, you see here to be the plane surface. Here is the incident ray, for example. Then we have the reflected ray. Then we have the normal. Now, all of the rays lies at the same plane here. So that gives what? The second law of reflection, which states that the incident ray, the reflected ray, and the normal all lies on the same plane. That gives what? The second law of reflection. So I put it down. The law states that second law of reflection, the second law of reflection states that the angle of incidence, states that the incident ray, the reflected ray, and the normal all lies at the same plane. So that gives what? The second law. This is the first law. The angle of incidence is equal to angle of reflection. Now let's look into calculation. So a question on the board reads, a ray of light is incident on a plane mirror at an angle of 35 degrees. What is the angle made by the reflected ray with the surface of the mirror? Then we have the options given. Now, solution to the question. A ray of light is incident on a plane mirror. Let's say we have a plane mirror here. Now we have this very plane mirror. Here we are going to have normal, right? Here is normal line. Now, a ray of light is incident on a plane mirror at an angle of 35. Now, this is the ray. Now, this ray is incident to this very point at what angle? Angle of 35 degrees. Now, what is the angle made by reflected ray with the surface of the mirror? Normally, when this incident ray hits this very surface, it will reflect backwards. Now, this is the angle of what? Angle of reflection, which will now be equal to what? Angle of incidence. But the question says, what is the angle made by the reflected ray with the surface? Here is the surface. So we are now asked to find the very angle here. So if the angle here is theta, then what is the angle of theta? Now we've seen that R, which is reflected angle, is equal to what? 35 degrees. And the angle here is right angle triangle, which means R plus theta will give 90. So in that case, the theta now becomes what? 90 minus R. So our theta becomes 90 minus 35 because angle of reflection is the same as angle of incidence. So at this very point, we have theta as what? 90 minus 35. And if you do that, we are going to get what? 55 degrees. We have the correct option as D. Okay. So at this very point, we need to also observe this very angle made with the surface. The angle made with the surface is said to be glance angle or angle at glance. So if we have the incident angle to be 35, the angle at glance will be 55 because angle at glance and the incident angle sum up to give you right angle. Okay? If you have angle of reflection plus angle at glance, they will still give you the same thing. So the angle here is equal to angle here, which is angle at glance. So you have to know that should they ask you to calculate angle at glance. Let's take another exercise. We have another exercise on the board. It reads, a ray of light strikes a plane mirror at a glancing angle of 50. We have another question on the board. It reads, a ray of light strikes a plane mirror at a glancing angle of 50. Calculate the angle between the incident ray and the reflected ray. So at this very point, let's make some sketch here. A ray of light strikes a plane mirror. Now we have a plane mirror here. So if here becomes the plane mirror. Now this ray strikes this plane mirror. Hence, we refer this as the incident ray. Once a incident ray strikes a surface, it's bound to reflect backwards. So we have the reflected ray. Normally here it becomes the normal ray. Okay. So a ray of light strikes a plane mirror at a glancing angle of 50. So the glancing angle here is 50 degrees. That's the glancing angle. Now calculate the angle between the incident and the reflected ray. Now here is incident, here is reflected ray. So we are asked to calculate the total angle here. So here you know that angle here is what? Angle of incidence. Then angle here is what? Angle of reflection. Now angle of incidence is equal to angle of reflection. So in that case, we can now term the whole angle here to be 2i because incident angle plus reflected angle, which is also incident angle, will give you I plus I, which is 2i. So in that case, we can get this as what? I, here as also I. Or you can solve it as usual. If here is 50, automatically the angle here will be 40. Why? Because sum of angle at right angle is what? It's 90 degrees. Now, if here is 40, here will still be what? 40. So you now see 40 plus 40 is 80, which is equivalent to what? 40 times 2. So the angle between incident ray and the reflected ray now becomes what? 80 degrees. And that gives the correct answer to be D. Okay, we have a question on the board. It reads, two mirrors are inclined as shown in the diagram. A ray of light, RO, strikes the arrangement at O. Here is RO. It strikes the arrangement at O and emerges along PO. The emergent ray has been deviated through what angle? We have option 240, 180, 120, 60 degrees. Now, you see the two mirrors. This is the first mirror. Now, this mirror, the ray hits this interface. You know, this ray should have been moving across this very path. But because of this path or because of the mirror, it reflects backwards. Okay. So the angle at which it deviates is this very one. So here is the angle of deviation. Now, on getting to the second medium, instead of moving through this very path, it deviates again. So here now becomes what? Angle of deviation for the second mirror. So we are now asked to find what? The deviated angles during the what? During the progression. So in that case, the total deviation now will be d1 plus what? d2. That's the what? Angle of deviation. So at that point, you have here to be what? 60 degrees given in the question. Now we are looking for d1 and the d2. Now to get this very d1, first we have angle here to be incident angle. Now if here is the angle here plus angle here should give us 90 degrees because here is right angle. So in that case, here is already 60. That means here will be 30 degrees. That incident angle now is 30 degrees, which means angle of refraction will still be what? 30 degrees. Now the total angle here is 60. Okay? Now, sum of angle on this very straight line, we have the straight line here. Sum of angle on this straight line now becomes 30 plus d1. Okay? So in that case, d1 plus 30 plus 30. 30 plus 30 is 60. Okay? Equal to angle on a straight line, which is 180 degrees, right? Reason, angle in a straight line. So our d1 now will be 180 minus 60, right? Which will automatically give what? 120 degrees, which we've got what? The d1. Now, to get the d2, at this very point, we can work out angle here. Look at here is also a normal. It's a normal line to the second surface. Okay? Now, if here is an angle of incident, we can get alternate angle there. Okay, we can get alternate angle, or even here as well. Look at this line now. Angle here is alternate to angle here. You see the alternate. This line is parallel to this line. So alternate angle, angle that forms here, being equal to angle here. So here is 30. And if here is 30, automatically here now will be 60. Because sum of angle in a right angle is what? 90 degrees. So if angle of incidence at the second mirror is 60, angle of reflection will still be 60. Now let's check the total angle on this very straight line. 60 plus d2 will give us what? 180. Then we get the value of what? d2. So in that case, we have 60 plus 60 is 120, right? So 120 degree plus that d2 is equal to 180. Reason, angle in a straight line. Okay? Now make d2 the subject. You are getting 180 degrees minus 120, which will now give you what? 60 degrees. Now we've got d2 and also d1. Our d2 here, we have it to be 60 degrees, while our d1 here, we have it to be what? 120. So if you add both of them together, we are getting what? 180 degrees, which is the required answer. So the answer here is B. So if what we did, we're able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class.